right, welcome to another episode of Let's Make It. And you're going to notice some differences this week. And this is something we're just going to try. I'm still in the studio. I'm just in a different location in the studio. This is actually where our technical director sits when we have somebody in here switching for us. But let's make it so it's another possibility for another just set of thing in front of the brick wall all the time. So we're trying it out. I also have made some changes, technical type changes, so I want to make sure that I'm close to the consoles to be able to fix them if needed. So, and what you see behind me, really, I can show you what it kind of looks like. Here is an overhead shot. So you're way up there on top of one of the monitors, but you see behind me is a green screen. Ultimately, I want to put something behind there that's more permanent, but I'm just playing with different ideas at the moment. So just a green screen, and I can put anything I want on there. So, but it's just to try to get. I like that kind of wood. That's the thing about putting behind it, and then just mounting some possible TVs or monitors on there or something like that. So I was just trying different backgrounds. I'm going to be trying that over the next couple of shows. Actually, now today I'm not actually needed to be in the studio. I don't need the overhead camera today because everything I'm going to do is going to be pretty much on screen on the computer. So you're not going to see much of me in my clean shaven face, since you probably haven't seen me since I shaved it, because last week we didn't do a show because I was under the weather, and so was Bob. So Bob is still under the weather. I've not heard from him in a little over a week. In fact, the last person I heard from was his wife. He had gotten the flu or thought it was the flu, but they thought maybe it was something else. So, but I haven't heard anything since then, and wish him well. Hopefully he's feeling better. And back at home. So, but this week it's going to be just me, and I actually got a request. I don't know if I remember this week or last week. It all kind of run together because last week was kind of a blur to me. Not feeling good all week. I originally was going to do the show again on Wednesday night, and I tweeted that out on Monday because I was sick. But when it came Wednesday, I still wasn't feeling very good, so I didn't do a show then as well. So I kind of skipped a week, but in the meantime, I actually got a request for something that we've kind of covered in the past, and I probably should have gone and looked it up. Actually, right here I am. And let me see if I can go find out what episode it was. And that is talking about Ethernet. So the request was for Ethernet and wireless. Well, I can't say I've done anything with wireless for wireless Wi-Fi on an Arduino. So I'm going to start looking that up and do some research on it. But a few episodes back, let's see where that was. So I'm back to episode 19, still going. I did do a Raspberry Pi Ustream checker basics. I think somewhere in there I did also the Ustream checker with an Arduino. It might have been that same week that I did that. So we never really covered it in great detail, but that's what I'm going to cover this week. And I'm just going to, and it's actually a very easy week for me because I just used the sample sketches that come with the Arduino, and they're really good. Now I've also written one, and it's what I've been doing for the last half hour. That's why we're running just a tad bit late tonight, a few minutes, because I wanted to write something to demonstrate a real world example, and actually one that I've been meaning to build for myself, and I just built it in the last half hour. And I'll show you what that is. But tonight, basically, we're going to talk about a few things before we get started into the actual code. There's a couple ways you can do Ethernet on an Arduino. So I'll see if I can hold this up. Basically, what I have here is an Arduino Uno and then an Ethernet shield that's plugged into it. This is what I'm going to be doing all the sketches on tonight. So I have the first sketch loaded that we're going to walk through. Then I also have here a Arduino Ethernet. So this has Ethernet built onto it. So you don't need additional shield to do the Ethernet. So you also notice on this one, this little bar is in here. Now I wish I had the overhead camera. It is actually a PoE injector. So you can put power over Ethernet and run this whole device off of one cable, the Ethernet cable, and the power is included in it. Now there are some drawbacks to that. You'll notice this board is a little bit tall. So the boards that I've created actually have a problem with it, with the height. So I have to, if I'm going to use one of these, I have to think through that. However, this PoE module doesn't come on all of them. It's an optional thing, and it's a little bit expensive. So if you're just getting the standard Arduino Ethernet, it doesn't have that board on it. Now I have another one here somewhere. but I couldn't find it. It's probably in a project box somewhere. I didn't take everything apart to find it. That doesn't have this, and it works fine for my shields. That just means I got to plug in power to the power for the Arduino. Or in the case of this one, the other thing you're going to notice on this is there is no obvious place to plug in USB to program it. That's because it doesn't have a built-on USB to serial chip. So what you have to do to program this shield or this Arduino is to get one of these. Basically, all this is a USB. You see the USB, mini USB right there, and this side is serial. So it's a USB to serial, and to program this board, you basically connect it together right here. I have a pin back in the back that is a 90-degree pin. You stick on here and you plug this in, and that's how you program this board. So you have to have one of these to program the board, or something similar to it. Other people make these. There's nothing magical about them. All it does is converting your USB to serial. So you can make your own if you really wanted to make your own. But in my case, it's just quicker to buy one of these. So that is a drawback to it. You just can't plug it in with Ethernet without having this additional little device. However, this one little thing is very easy, and it stops. Let me show you what my other project's gonna look like here. This is the other project, and you see on the bottom, I have an Arduino Uno. You see in the middle, I have an Ethernet shield, and you see on top is one of my button shields. And you see this big sandwich looking thing where if I could do it all with just this one like this, I could get rid of this whole middle section and it'd be down to just, it's nice and small. So there's definitely an advantage to using those kind of boards. In some cases, you don't care. And if you don't care, it's actually a little bit easier, a little more flexible to have the Ethernet shield, because you can just take your regular Unos or Leonardos sitting around. You can actually do this also. If I'll probably show us at some other point in time, we actually use the Ethernet shield with Omega as well in one of our things we've been playing with. So that's just another way of doing it. And there are other people out there make Arduinos that have it built in. One of the things you're going to notice, and this is always pretty much the case, is that when you have these Ethernet shields also, what you're getting is an SD card reader. And that's mainly because they've connected this SPI. So on a regular Arduino, you have this little pins in the back. It's called the SPI. And that's how they're communicating with the Ethernet. But they use that same pin configuration, and they just go directly into this SD card because it pretty much is a direct connection to the SD card. There's a few little additional pieces needed in there, but not really that much. So it's very simple to go ahead and put in the SD card reader. So that's how it is on the Arduino Ethernet, as well as if you look at the Ethernet shield, you will see on the back side right here is an SD card reader, and that's very common. And typically, if you want an SD card reader, you're going to get Ethernet. It just always seem to go together, but that works out very well. Okay, so a few things I want to talk about. I mentioned I was out last Monday, and we never did a show. I'm sorry. We tweeted that we're going to do it on Wednesday, and Wednesday just still didn't work out. And again, Bob's still out. Hopefully I get a status update on him here soon, at least from him or his wife, since my last one was from his wife. And we're in this little new area today. And we're in the new area. It's kind of a little bit of experiment to see how this is going to work. And I think normally we're going to be back in the other room back here with the brick wall behind me and all that stuff. But it's an interesting try because some of the new shows we want to bring on are going to be needing somebody here and somebody in there, and the person here probably being a co-host as well, just because of there are so many people that are involved in a couple of these new shows that are coming out. And let's see, there was one other thing I wanted to cover. I'm going to look at my notes here really quick before we hop into the Arduino stuff. Well, I'll think of it along the way. I do also want to note that with the holidays coming up, I'm not quite sure what our schedule is going to be. I think Christmas Eve falls on a Tuesday, so we may still do the show on the 23rd, but I'm not positive about that, and if might do the one next week as well. However, this month in December, we are going through a lot of our shows and restructuring them, changing graphics around, and doing a whole new look for different things. So coming in January, we have new shows coming on. We want a new look or a little bit different change. This show is not really going to change that much, other than I might want to start bringing some more people on as like weekly guests or something like that. That wouldn't be not replace Bob. Bob will still be here as long as he's healthy and wanting to come here. But we want to start bringing on some other people that have made some cool things and wanted to show it off. And we've been offering that, and we've finally gotten a couple people that may want to do that. Some of them are a little shy, so just kind of push them on a little bit. I have gotten a lot of emails this week. That's actually something I should probably cover too. I've gotten 3 or 4 in the last couple of days, and I haven't responded to one of those. I get the rest of them probably tonight or tomorrow, but I try to respond to as fast as I can. And like always, I'm a little slow at responding with all the things that are going on here. And tonight's show was actually a request in the last week or so. Let me go over here and I'm going to look at my emails. So I got a couple of things. Jim from Canada has been going back and forth with a couple of things with me this week, and which is very good. And I had a couple of questions about a keypad lock, some questions about other kinds of types of tutorials. I had this one about tonight, which with the Ethernet. Some people are having some LCD display issues. Gennaro is having still problems with the serial LCD, and I'm not quite sure what to do to help him because he has it all hooked up right and has the code in there correctly, and he has the library. So we're still trying to work out that. Let's see, who is this one? Well, I had a question kind of about a calculator too, which is a little interesting. I'm trying to figure a little more about that one. Future podcast suggestions. Here we go. Portable LED light using Arduino to control LED's brightness and change modes, flash, strobe, etc. So that may be something we do in the future, and that's kind of things that Bob likes to work on. So it's very possible that he'd be the one that would do that. So that's another great suggestion for a future show. Let's see. I don't know. There's a bunch of things out there, a bunch of emails this week. And Elver I got today was asking questions about countdown timer as well as like controlling an AC. So he's like multiple projects in one that we've covered in the past, and we'll maybe work with him to try to get different pieces of different projects put together to do that as well. All right. So I'm going to take a quick break. We've been going here for like about 17 minutes or so. And I'll be back, and we're going to walk through some of the code that I have loaded on here and tested. We're going to show you some of Ethernet control with the Arduino. So we'll be back momentarily.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our great listen guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
All right, we're back. And I do want to say, if you are into books, I am an Audible listener, and I do that all the time. And you know what the coolest thing is? I'm setting it up with a subscription plan where you get, I think it's 1 or 2 books a month. And I go in there and I download a bunch of books at one time, and I put them on my phone and listen to them as I drive around. And then I go back in and look and see what's new. And I got more of them in there, so I get more books. So I have a wish list that's growing in there faster than I'm buying them, though, unfortunately. But there's a ton of good books on Audible. And if you're into books, but you don't have the time to read them, listen to them is just as good. You can download them, listen to them in your car. If you listen to them at home or sitting out on your deck or whatever, you can listen to them. I just listen to them when I mow their lawn sometimes too. I'll bring up a book that I'm listening to, and it's one of those things where I just can't stop listening to it. And I have a wide variety of books to listen to, from anywhere from business to self-help. I do a little bit of stories, but there's a couple other good books out there right now that are nonfiction that came out that I'm looking forward to getting as well. And they're in my wish list. So if you're into books, try out Audible. You can get 2 free books by using the link that's on the bottom there. So definitely check out our sponsors as well. We love our sponsors, and it's definitely benefits us whenever you go do that as well. And the one thing I forgot to do in the beginning was just do our normal housekeeping type things, because I'm not in the other room where the things in front of me to remind me to do it. And that is that we do the show live every Monday night, unless we're sick. And I was sick last week, unfortunately. Feeling a little better this week. But anyways, we do it live every Monday night. You can come in, join us in the chat room and chat, and we'd love to have you in there. So if you're in chat, we can actually come and you can ask us questions and kind of guide the show where you want the show to go. And I'm in here watching it as we speak. The other thing is, if you are not watching us live, try us live. I think you'll really like it. But if you're not available to watch us live, I completely understand. We do it at 9 p.m. Eastern. And if you're somewhere else in the world, you just can't happen to do that. If you're on the West Coast, that's 6 p.m. Maybe you're stuck in traffic. But you can always get it through downloads through iTunes or Dogcatcher, Podcatcher, any of those catcher type things that are very popular. We're at most of those. And if we're not there, let us know and we'll get there. We also have a Roku app. You can watch us on YouTube by going to youtube.com/TechZenTV. All of our shows are uploaded there as well. So you can get it either automatically on your device and downloaded through podcast, or on demand at YouTube, or we also are on Roku, like I said, and we're supposed to be on TiVo. And I just checked with them last week, and they said they were confirmed that we are there. I don't have a TiVo anymore, so I can't say that for sure. We're also on Stitcher and all the other audio ones, but this show in particular is a very visual show. It doesn't make much sense to listen to this show. It makes sense to listen to it, but it doesn't give you the same benefit as listening only. All right, so let's get into what I have here, and I showed this already to you, is a Arduino with an Ethernet shield. It's sitting here in front of me. It's plugged into a gigabit interface, although it's only 100 megabit, but it is going to gigabit, and plugged in my computer. And what I'm going to do is, let me get out of what I'm in right here, and I'm going to switch over to the computer, and we're going to do our first sketch here. So the very first one we're going to do is a DHCP address printer. So if you're not familiar with DHCP, basically it stands for Dynamic Host Configuration Protocol, but besides the long name, basically it takes and assigns an IP address to your device automatically just for it requesting it. Now the Arduino doesn't have any of this stuff built into it. It basically is a piece of hardware and requires software to do this. So there is a library for this, and we're going to scroll down through here, and you see there's a SPI, and the reason the SPI is there, that's how we're communicating with the Ethernet. And then we have the Ethernet. So this is actually a demonstration. If you go to File, Examples, and you scroll down here and you see Ethernet, these are the ones I'm going to go through some of these tonight. I'm going to go through all of them because I think it's a little bit overkill to go through all of them. But we're right now on this DHCP address printer. So what it's going to do is it's going to print to the screen what the current address is, or print to the serial port. And we're going to scroll down through here. So we define SPI, which again, this is the communication method to the chip. And then we define Ethernet.h. And then we define a MAC address. Now here's the thing, like I said, this is only a hardware device. it doesn't have any information programmed into it. So unlike your NIC card that you get and you put in your PC, you actually got to tell it what its MAC address is. So we have it set up. This is the default that was in here. Basically, it's A, B, C, C, D, E, and then O2. And that really, I have not looked up to see what manufacturer that is, but typically the first 3 are the manufacturer code, and then these last ones are increasing based on the manufacturer's serial number. So you can make up anything you want here, as long as it's not going to hit a device that's already on your network, and the likelihood of you doing that is pretty slim. So we're going to leave it like it was by default, which was the AABB. And we come on down here, and you see we take the Ethernet client, and then we define a class called client from that class. And you'll see why here shortly. And then we come down to setup, and we're going to activate our serial port at 9600 baud, and we're going to wait for the serial port. I've never done this before, but these examples have this in here. I've never had this problem with Leonardo, but it's a potential that it has a problem. So we'll just leave that there. All right, we start the Ethernet connection. So we go to ethernet.begin, and we give it the MAC address. So if it comes back with equal to 0, it means it could not get a address. So we're going to print to the screen, failed to configure Ethernet using DHCP. And if you don't have an address, you can't go anywhere, so we may as well just not do anything else. So we don't. We just sit here in this loop forever and go around this loop. But when we get that address, and we get through this address, this file, we come down here, we're going to print to the serial port my IP address. And we're going to do this. And the reason we do this in 4 bytes is because a IP address is 4 bytes. It is basically a 32-bit IP address, and that's assuming you're on IP version 4. IP version 6 is a whole different discussion that we probably aren't going to discuss in this show, at least not with our Arduino. So what we do is we loop through the 4 bytes that we got back, and the first byte is the most significant, or the class A location. So we print that out in the decimal value, what we got back. We print a period, and then we get through and we keep doing that the whole way down through B, C, and D. And then we print a blank line, and that's it. That's all it's going to do is just print out the address that we got back. So let's go up here, and I'm going to make sure I uploaded this. I'm pretty sure I did already. All right, done uploading. Now we're going to go to Tools and Serial Monitor. And there you go. That's the IP address it got, 10.232.1.103, which is an address in my DHCP pool here. All right, that was sketch number 1. Very simple, but gives you a quick example of how to get an IP address. And some of the others we're going to do are actually going to fix an IP address, so it won't be dynamic like that. So let's go and get out of this one. And let's see, what other ones do I have open? Here's the one that we all kind of know. It's a web client. Again, this is one of the examples that came with the Arduino. It's in the Arduino library. And again, we get the Ethernet shield. Standard Ethernet shield is pins 10, 11, 12, and 13. So that's correct. And you see here we have the 2 things, SPI, and we have Ethernet. And we have a MAC address. You see this one's different. It doesn't really matter what MAC address you use. And okay, so we're going to define an IP address, static IP address used if DHCP fails. So, okay, well, if we go there, we define our server name. We're basically going to request something from Google. So www.google.com. We all know what Google is. And I'm actually going to change this address because if it does some reason fail, it would not get out with that address. So I'm just going to set it up high. All right, so we define Ethernet client, and we call it client here. All right, go through setup, set our serial port up, and then again, we're waiting for the Leonardo. And come down, and we start our Ethernet. So we give it a MAC address. And here's the thing, if you do begin with no IP address, DHCP tries to get an address. However, if this fails, it's going to say Ethernet begin MAC, and then the IP address that is put in that box up there. So it's going to assign it an IP address. All right, and we're going to give it a second to initialize. And again, I don't know if this is some kind of timing issue. I've never experienced a delay here, but if they left it in there, I think it's a good reason to try it and leave it in there. So we give the connecting, and here's where we come back into client now. So we now want to connect to the server, which is www.google.com on port 80. So if you know anything about the web, port 80 is the encrypted web, and 443 is the encrypted web, or the SSL web, where your data is protected. So we're basically going to do a clear request to Google on port 80, which is the web. So we're going to then, if it connects successfully, we're going to go ahead and print to the serial port that we've gotten connected, and then we're going to do a search in Google by doing a get. This is an HTTP request right here, get. And what we're going to ask for is /search Q equals Arduino. And that's going to be like you going to Google and typing in Arduino in the search field. Here we define our host, www.google.com. And this is all, and then we also say connection closed. So what we are basically doing here, and the reason this is all here rather than just the www.google or the search, is we got to make it look like what your browser does. So this is what your browser would do if you would search, if you would go to Google, www.google.com/search Q equal Arduino. This is what it would really be doing behind the scenes. It'd be doing get, and then this search. This is telling it what version of the HTTP protocol we're using, which we're using 1.1. And then our host is www.google.com, and the connection we want, after we're done, we want to close it. And then this is all being sent to the Google server. And if we didn't connect, we just say connection failed, so we don't do anything. So that's all done in the setup. So that's our single request we make to Google. And now in our loop, what we're going to do is we are going to print to the serial port everything that we receive. So right here, if client is available, so we have client data available, then we read the character in and we print it to the serial port. And we're going to do this loop continuously. Now, if it's disconnected, if it's not disconnected, I'm supposed to say, and we're going to disconnect basically. So if it drops us, we're going to cleanly disconnect on our side. So if the client gets dropped from Google, say Google gives you everything you need and it drops the connection, we're going to print the word disconnecting and we're going to stop our side. And then when that happens, basically we're done with our request. So at that point, we do nothing. We can sit in this loop forever. So all this loop's going to do is going to sit here and keep reading data as long as it can over and over again. Eventually, the connection is going to time out. And whether it's lack of data or whatever, for whatever reason it times out, when that happens, we're going to disconnect right here. So we're going to run this. We're going to go ahead. We're going to upload this. All right, now we're going to go look at the serial monitor. And you're going to see a lot of stuff start coming down in a second. Okay, so here's the stuff that's coming back from Google. And it's going to take a while to print to, because I'm printing it to my screen at 9600 baud. So it could go a lot faster over the internet, but coming back to us on the screen is going to be just a little bit slow. And luckily by now, all the data has been retrieved. It's just still coming back to the serial port. So every time you go to Google, this is what your browser is bringing back. It just happens so fast, you don't see it. And when we slow it down to 9600 baud, it stands out. We're still in the functions for JavaScript. Haven't even gotten to the results page yet. There we go. Now we're getting to the results page. And it's going to keep on going and going. There, it's getting a little more interesting. So this is probably really a bad example of a page. This is what the example was that was in in there, but we should probably go to something that's a little less formatted. I mean, the Google's page is formatted. That's why you're getting all this stuff back. And you see all the different sizing in there and the divs or the divisions. There we go. So here you can start seeing some of the results that are coming back. This was formatted on a web browser. It will look really good to you, but just because it's in here. So right here you see connected. HTTP 1.1 200 okay, so that comes back from the other side. Basically, when you connected to Google, Google said 200 okay, I accept your connection, and it brings back the data information. Here's the cache information. So basically, it tells you the type of content. So cache control means private, which means it won't cache it. It already expired. -1 means it's already expired when it comes in. So next time you look for the same thing, it's going to re-download it again. Content type is text or HTML. And here's the cookie information that's coming back. These are your cookies right here. P33 is not a P33 policy, so it talks about policies and security. The server is a GWS server, which is a Google Web Services server. So here we have cross-site scripting protection. All these different things are in here coming back. And then we finally get to the part where you wanted to get to, which is the document itself. So here's the HTML document, and it's coming down, and then at the very top, you're going to see that's what all the scrolling to the right was, and this very first couple of lines here was all the formatting information that comes down first, so it knows how to display everything. So basically, what you just did is you did a single lookup in Google by doing this. Now, one of the things that's you got to kind of look at this and remember is, just like you do serial print line, you saw here we're doing client print line. So you already know how to do this requesting. The only part that's different is this Ethernet begin and the client setup. So when you come down here, here's your client connect. So you have two things. You have Ethernet and you have the client. Ethernet is your IP address and your MAC level, and the client is what makes the request to the server. So we define the client right here, Ethernet client, and it works with the Ethernet. So it requires you set up the Ethernet, get your IP address configured, and then you go to the client right here and you can connect it to a server on a particular port, and then you can do client and you can do print lines, and just like you do anything you do with serial, you can pretty much do with the client. You can do prints as well. So there's a couple other things in there, and if you go look up in the Arduino site, you can actually get all the different possibilities that there are here, and you're going to see some more of these as we go through some of these other ones. So that was the web client. Basically, just grabbed a single web page. All right, that's I'm not going to save that. And here's one's a little bit more complicated, and you may not be familiar with this, but if depending on what kind of computer you're on, you may already have it and don't know it. This isn't a script. Yeah. This is a sketch. Oh, I said script and then lost the name of my head. This is a sketch that's going to do NTP. So what NTP is, it allows your computer to go to a public time server and request the current time. So most people go to the time server like once every 15 minutes or so, and that sets up your clock. Now, if you're on a Mac, this happens all automatically. Let me get rid of something here or embarrass somebody. But that happens all automatically on your Mac. Now, PCs don't all do that, but there's some services you can turn on that do that. I said do. I know. There are some services you can turn on that will do that. And basically, most people go to, there's a whole thing here. If you go look up NTP, there's strata in different levels. So if you would go directly to the atomic clock, that'd be the top strata. And like GPS is a strata 1, so it basically gets its time from the atomic clock. So if you have a GPS receiver like your phone, it's going to be accurate to the top level atomic clock type location. So there's hundreds and thousands of NTP servers that are on the network, and most companies will most large companies will put an NTP server in their network so that all the computers in the network can go locally instead of going out to the internet to get it. And that way everybody in the company is synchronized to the same NTP server. So anyways, what this script is going to do Okay, there I said script again. What this sketch is going to do is going to make a request to an NTP server. And it's actually a NIST NTP server. And National Institute of Standards and Technology is a very popular NTP server. I think it's a Strata 2 server, which means it's like 2 levels down from like the atomic clock type level. But it's still very good. And actually, as long as everybody's synchronized to the same clock, unless you really have a need to be down to this absolute partial of a second, there's no real reason not to go to Strata 1. But anyways, let's go down here. So here's the thing about NTP. NTP is UDP based. Now, I didn't mention this with the WebWin because I don't really want to get into a complete networking discussion. But web calls are TCP based, which means they have consistency and persistence with connections. So when you connect to something, you are connected to it until it hangs up on you. That's why you saw that thing in there. It said if it disconnects to go through and close it down. In the case of UDP, it's connectionless. So basically, you're throwing the request out into the Ethernet and hoping it gets there. If it doesn't get there, you don't know it didn't get there. The only way you know it didn't get there is you don't get an answer back, and there's no guaranteed delivery. So and that's kind of like a ping. If you ever tried doing a ping from your house to a server somewhere and you get dropped packets, that basically means it didn't get there because it's not guaranteed delivery, where TCP is guaranteed. You will not get connected unless you're guaranteed to stay connected. So UDP is connectionless. It doesn't track, it doesn't reassemble packets. It's very much a broadcast and forget type technology. So NTP is UDP, and you're going to see in here how it functions a little bit differently. Again, this is a example right out of the Arduino. So we're going to scroll on down here. And you see we have the SPI and Ethernet like we had before. And now we have the Ethernet UDP. We have additional one here because UDP requires an additional library. And here you see the MAC address. And we're going to define a local port to listen for UDP packets because we're connectionless. Basically, we're going to send a UDP packet and we're going to receive one, but we don't receive it through the same connection that we went out because we're not connected. So we got to tell the other side where to send it back to, and we got to be listening for that packet. All right, so we're going to set up an IP address of the time server, and this is the time server at bldr.doc.gov, which I believe is still NIST. I don't remember, but I checked this out earlier and it did still work because I know they move these around. I wanted to make sure I wasn't going to be experiencing a little bit of a problem, during the live show here. All right, so we set packet size equal to 48, and I'm not going to go into great detail into this, but if you look up NTP, and I'll tell you what I'll do. I'll put a link to NTP standards, the RFC document, in the show notes. I'll make hang on, find a pen and make a reminder to myself to do that, because if you read the RFC, it may make more sense. RFC to NTP. So the RFC is the document that describes these protocols. It actually stands for Request for Comments. But if you go out and you search for RFC and NTP, you'll find it. I don't know the exact number that it is, and actually maybe it'll look it up here. Let's see. NTP 5905. 958. There's a couple of them actually. Depends what version of NTP you're talking about. NTP version 4, which is the latest, is 5905, RFC 5905. If you're looking for, I believe, version 1, which was looks like 85. September 1985 is when an NTP was first designed, and it was RFC 958. So there's also a good Wikipedia article here. So I'll put all these links out there so you can go look at it. But one of the things you can use NTP for also, while I'm thinking about it, with an Arduino, is Arduino doesn't have a clock in it. So if you had some way of keeping track of time, you could occasionally, like every 15 minutes, go out and do this check and reset your time, and use some other system to keep track of time. That it doesn't have to be very accurate if you keep checking what time it is and resetting your time. All right. So anyways, I'm not going to go into the great detail about the actual protocol, but if you go out to the RFC, you can see the protocol. Basically, we're talking about a 48-byte packet. And so we're defining the packet size right here as 48 bytes, and the packet buffer is a byte array, and it's NTP packet size right here, so it's going to be 48. We define Ethernet UDP class as a new class, UDP. So we're ready to go there. In our setup, we do our serial, which is very common. And we start our Ethernet. We define a MAC address. Because we're not specifying an IP address, it's going to get a DHCP address. And if we are good with that, then we're going to begin listening on local port. So udp.begin starts the listener on local port. And up top, so local port was 8888, I believe. Yeah, right here, 8888. All right. And then we're going to come down here and we're going to send a packet to the time server. Remember, we said the time server up top was that IP address of the NIST machine right here. So time server is 132.163.4.101. So here we go. We send our NTP packet to time server. And then we are going to wait for a second to see if we can answer back. If it takes more than a second, more likely the packet got lost somewhere. Again, this is not a guaranteed delivery. The packet you sent could have got lost. The packet coming back to you could have got lost in either direction. However, if we do get a packet, so we're going to do this parse packet, which means we received a packet. We're then going to do a UDP read into packet buffer, and then we're going to read 48 bytes back right here. The timestamp starts at 40. That's 40 byte number 40, and is 4 bytes long. So if it's 40 through 44, and we're going to do some a little bit different type of calculations here. So basically what you're getting back is the number of seconds in a integer or a long integer. So it's coming back in 4 bytes. So what we have to do is we have to take, and we're going to make a word out of the first 2 bytes and make a word out of the second 2 bytes. So here you see us taking this, because a word is 16 bits or 2 bytes. We're going to take the first 2 bytes, make it into a word, and it's going to be a unsigned long high word, and then we're going to do that same thing with unsigned long low word. And then we take those 2 that we have, we shift the high word 16 bits to the left, which makes it the top 16 bits in the long integer, and then we OR to it the low word. So we basically took all of these and made a 32-bit long integer. So right here we have unsigned long. And this is the number of seconds since 1900. That's how the time server returns to you the current time. Even though we're in 2000, it's still going to give you the number of seconds since 1900. All right, so here we're going to print out number of seconds since January 1st, 1900, and we're going to print that out so you can see what came back. And then we're going to convert to Unix time. So Unix time is also number of seconds, but it's number of seconds since January 1st, 1970. So we need to subtract 70 years exactly. So 70 years is equal to this long number of seconds right here. And when we subtract the 70 years from the current time, we have what we call epoch, which is what Unix time uses. Unix uses to keep track of time. Essentially, it is number of seconds since January 1st, 1970. So now we're going to print that out. We're going to print to the screen what the epoch is. And now we're going to come down through here and we're going to actually print out what the current time is. So here's how we do that. We know how many seconds it's been since 1970. So we'll come down here, and actually we don't even really care at this point. If we wanted to know how long it's been, we could do that. But what we're looking for is time. If we wanted to know the date, we would be more concerned about how many seconds it's been. But what we're going to do is we're going to take epoch and we're going to divide it by 86,400. And the 86,400 is the number of seconds that are in a day. And this percent sign basically returns what the remainder is. So we divide epoch by 86,400 and return the remainder. We then divide the remainder by 3,600, which gets us the number of hours, because how many seconds there are in the hour, in an hour. And if that is less than 10, we are going to I'm sorry. No, we're going to print that out. We're going to print a colon. And then we're going to take epic and divide it by 3600 with the remainder again. So there's the percent sign. So we're going to divide by 3600. Whatever the remainder is, we're going to divide it by 60. And if that is less than 10, meaning that it's like 1 through 9, we need to add a 0 to it because we want to be colon 01 or colon 05. So we're going to print a 0 out. And then we're going to print to the screen the same result, epic divided by 3600, take the remainder of that, and divide it by 60. And that's how many minutes that we are in the hour. And then we're going to do a colon, and we're going to do epic divided by 60 with the remainder again, so that we're down to the minute, or down to the seconds now. So anything that's remaining is actually a number of seconds that are in the remainder. And if it's less than 10, again, we're going to print a 0, and then we're going to print out whatever the calculation actually is. And we're going to wait 10 seconds, and we're going to do it again. Okay, so now let's get down here where we actually send the NTP packet. This is the actual workhorse part of it. So what we're going to do here, and again, this is a very protocol oriented. So if you go out and look at the RFC, you'll see what all this is doing. But basically what we're doing is we're setting up this is binary right here. So you see 0B, and it's an 8-bit binary. This is a version in mode. So actually, it tells you LI version in mode. So these all have different values, and these different bits mean different values. And then we say a type of clock. It's a stratum. So we say it's equal to 0. Polling interval is 6. I can't remember what the polling interval does. It's the, and then there's the pure clock precision. And again, this is defined in the specs. And then there's 8 bytes of 0. And then there is a 49, a hex 4E, a 49, and a 52. I don't know what those are. And you will notice the packet buffer is not full here. We define the packet buffer as 48 bytes, but that's because the receiving packet is 48 bytes, not because the sending packet. All right, so now we come down here and we begin packet. So we do UDP begin packet. We give it the address, which is the address of the NTP server. And the 123 is actually the port. The port that NTP listens on NTP server is port 123. So that's not just something typed in there, 123. Then we do UDP write, and you notice right here it's not print line or anything like that. It's just write, which means there's no carriage return applied here. So we write the packet buffer out, and the packet size, again, that's 48 bytes. So anything that wasn't written, 16 and above, is all zeros. So the packet's going to go out with zeros on the end of it. And then we do end a packet. So, and then that closes the port down. So we open the packet. It basically opens a function, for lack of a better word, to this address, this port. You're going to write this out, and then when you end packet, it actually goes out the Ethernet interface. So again, there is no connection per se. You're just pushing it out the port, hope that it gets there. So let's go ahead and we're going to run this real quick, and we're going to see what this is doing. Let me upload this. All right, and I'm going to go to serial monitor. All right, so here we go. Every 10 seconds is going to do this. So you see that the number of seconds is, and I can't do that in my head, 3,595,632,829 seconds since January 1st, 1900. If you take away the 70 years, we're down to, what is this? 1.3 billion. So 1,386,644,040 seconds. And that ends up being UTC time of 254. So it is right now 254 and UTC. It's 954 here. So at this point, you'd have to figure out what your time zone is. In my case, I am -5 right now. So that puts me at 954. So yeah, that works out good. That works out perfect. And so depending on your time zone and also your daylight savings time status would make a difference here as to what that is. All right. So let's go and see what else we have here. Do we have any more? All right, we have a chat server, and you know what? I tried playing this a little bit before the show started, and I couldn't quite figure it out, but I didn't spend a lot of time on it. But basically, looking through this, I can tell you what it does. It allows you to telnet to this, and it will have everybody talking together. The one thing that was confusing to me was, can it do multiple people at one time? And it looked like to me that it couldn't, but I'm not sure about that. To my knowledge, you can't have the Arduino do multiple things like this. But I very well could be wrong. And I'm going to play with this and here, but I didn't have time before the show. And let me look through here again real quick. So we're basically defining IP address, our gateway, which is wrong for me. And the subnet, that's wrong too. Setup, and you can see here Ethernet begin, MAC, IP, gateway, and subnet. In my case, I should probably just get rid of this and do this. So it's DHCP. Server begin, let's see, Ethernet server, which means you have a listener. And we come on down here and chat server address is printed to the screen. If wait for a new client equals server available. Okay, so if we have a client and we're not already connected, see, this is where I'm thinking you don't have more than one at a time, because right here it's client flushes the client. We have a new client, hello client. Already connected equals true. So let me do this. I can probably test this to see while we're right here. Server right, 0 right. It looks like I can only communicate to the person who connected, the one person who connected. Let's go ahead and upload this and try it. This is live failure. If it fails or it works. All right, it's uploaded. Serial monitor, I need to know what my IP address is. All right, let's go ahead and bring up. All right, 10.232.1.102. I'm connected. But I'm sure not seeing anything. Yeah, so this is one I need to play with a little bit more. It definitely doesn't work the way that I thought it should have. Nice server, but everything looks the same. Ethernet server. Port 23, which is what I connected to. I can make sure I did that. Oh, there it is. Hello, client. All right, let me see what we get now. It may have disconnected my telnet session. It did, but we can do it again. All right, so there you're seeing it echoes back to me what I type, and also echoes to the screen. If I send something here, what happens? Nothing. So it really is only an echo and one-way chat. So not a very functional chat server, but it does work. But it gives a good example of how to become a server to listen to it. So let me go ahead and get out of this and out of this. All right, so our last one, I think, don't save. Let me clean up my windows here a little bit. I want to show you a more real-world example. Well, I had a lot of windows open, didn't I? A little more real-world example of how I use this. I think it's the last one I had open, right? Oh, I still had one more. I'm not going to show you that one. We kind of covered that one with the NTP. Yep. Okay, this is the lesson we're going to do. So maybe it's not. Yeah, this is it. All right. So let me do this. I want to show you a little bit what I'm going to do while I'm changing it out. So I showed this in the beginning. Basically, this is an Uno Ethernet shield and a broadcast button shield on top. And I'm going to go ahead and, okay, it's all together. I'm going to unplug the other one and plug this in its place. All right, Ethernet. And you see it's going to go through a little dance. And for some reason I lost my red button. I haven't figured out why. My one red button's not red anymore. It was working earlier today, but it's not now. So basically what I have here is I have two green buttons. You can't tell what they're even on probably, can you? Nope, not in the camera, but they're green. You have to believe me, they're green. And what this is we have two things on our soundboard that we mute regularly. One of them is me, or wherever I am, because if I have to cough or something like that, I want to mute myself. Or in the other one is we can mute all the vocal mics. So like when we're doing the ads, we can talk to each other without having to you guys hearing us and talking on top of the ads. So what I've done is I've created a sketch that does exactly that with these two buttons. And give you an example is, well, that's one of the things that got muted right there. And did it mute to you? All right, we still got quieter because I didn't mute everything to you, but I muted some things to you. So anyways, that mutes one of the two. And then the other one would actually mute my mic. You can tell I got quiet. So that's what these two buttons do. And the way it does that is through Ethernet is this soundboard that I'm using, which is in a Behringer X32, has what's called OSC Protocol, or Open Sound Control Protocol. And I have the Arduino programmed to tell the soundboard when I press certain buttons. Now, the one thing I don't have that I didn't get done, that I'm still going to do, because I'm going to use these probably, is this is not reading the soundboard. So if I mute something on the soundboard, you're not going to see any change on the Arduino. I'm going to make it so that it's going to read the soundboard once a second or something similar to that. So if it gets muted, these will represent what the soundboard is doing versus having to look at the buttons that are on here. So these buttons are following what I'm pushing on here, but not based on the soundboard. So I hit a button. If it doesn't get to the soundboard for some reason, because again, this is UDP, OSC is also UDP. If for some reason it would not get there, this would be red and muted. Or if I muted it over here on the soundboard like that, this button doesn't change color to tell me that I'm still muted. So, but what I want to do is I want to walk through the code that I did to make this work as well. So that's the next thing we're going to do here. So if I can keep it from sliding off the desk here. There we go. Let's go back to the computer. And this is what I have open right now. So I don't have it documented yet, but I'll put this up there as well. And I'll finish it off probably tomorrow with the feedback. But basically what it is SPI on Ethernet again. And then there is another library called ZOSC. And this is somebody who wrote this OSC library. It's actually kind of nice. It needs a little bit of tweaking maybe, but overall, I definitely like it. Makes life a lot easier. So we're going to scroll down through here, and this actually came from I have another shield, with using the same buttons and the same button shield as this that does scrolling for script scrolling. So that's where I did this stuff before, and that's how I know I got it working. But basically, I'm using certain pins for the LEDs because they're PWM. And the pins that are left over, I just took and used them for the buttons. So button 1 is pin number 2, button 2 is pin number 4, and button 3 is pin number 7. Now you'll notice I only have 2 buttons, and it's actually put into button 1 and 3. So button 2 isn't being used in this particular case. And then each of the colors, the buttons can do red or green. So the button 1 green is pin 3, the button 1 red is pin 5, button 2 green is 6, button 2 red is 9, so 10 and 11 are red and green for button 3. And then this right here is an array, and you'll see later on at the bottom while I use this array, it makes it very easy to do certain things like turning all the lights off, turning all the lights on, things like that. And then next pin is used in that whole cycle along the way as well. Right here you see my MAC address. Again, this is a made-up MAC address. I have no clue. This note doesn't interfere with anything on my network. And then I fixed the IP here to this IP address. And the soundboard's IP address is this IP address. So again, that's fixed. And OSC by default is port 10,000. The X32 listens on port 10,023. And then you'll see here, and I've actually been doing some experimenting, as you'll see down through here, but basically these two aren't being used at the moment, and these two are. And then I have the muting of all the vocals is considered a group, and the muting of my mic alone is considered a channel. So you see I have a button, 2 different modes. I'm keeping track of the mode muted or not muted, and that's just so that when it goes around the loop, I can keep track of where it's at, and I know what to do with it as well. And in the X32, if we scroll down here, if you look up OSC Protocol, basically it's done, well, it looks like a directory. For lack of a better description, it looks like a directory. So in the case of the bus, the vocal bus is bus number 7. So bus 7 in mix on basically tells it if it's muted or unmuted. If it's on, which means it's true, then it is not muted. If it's on is false, then it's muted. So, and then we also see here a channel 9 mix on. And then I was also playing with changing the volume of the faders. So channel 9 mix fader, you'll see, I don't know if it's still in here or not, but I was experimenting with moving the fader to the bottom to the top, to the bottom to the top, just to try to figure out the OSC protocol a little bit with the X32. All right, so we come down here, and I'm going to define the OSC client as the word client, and you'll see that on down through here. We're going to set up our serial port, although I don't believe I have anything using the serial port anymore. I think the debug has been taken out. I'm setting up the pin modes for all the buttons. Even though I'm not using button 2, I'm still going to continue on because the board itself, the shield does have button 2 on it, being able to be used, just not there. And then all the lights are for output, all the LEDs are output. I'm going to begin Ethernet using the MAC and IP address that I assigned above. And then I have this, what's called a startup cycle, and basically I call it a light dance. So it's how I test the colors of the LEDs in the switches and how I know my red one's not working for some reason all of a sudden. All right, so we're going to come on down here a little bit farther, and we're going to go into the loop. And this is where most of the work is done. And if button number 1 is pressed, I am going to check to see what is the current mode. And if it's muted, I'm going to unmute it and change the mode to unmuted. If it's not muted, it means it's not. That means it's, if it's not equal to muted, that means it's unmuted. So I'm going to come down here, I'm going to mute it and change the group mode to muted. And we're going to come down here, we're going to do the exact same thing with the channel mode. So button 3 is for channel. And if, again, channel mode is muted, I'm going to unmute it and change its mode to unmuted. And if the channel mode is not equal to muted, I'm going to change it. I'm going to mute the channel and set channel mode to muted. So those are the two back and forth states that it can be in with these two buttons. And then I'm coming down here and I am changing, I'm setting the colors based on the channel mode. And the reason I broke this out from the buttons is I'm going to add in here the ability to read the soundboard to tell what state the button is in. So if I would stick it in the buttons, I would only be changing them whenever the button was pressed. I want to change that every time I come through this loop to see what the current state is. So well, I've separated these out, and if the channel mode is equal to muted, then I want the button 3 to be red and button 3 green to be false. And if it's not muted, I want the button 3 red to be off and the button 3 green to be on. And do the same thing in group mode, and then I delay 200 milliseconds. So you see what's missing in here is reading of the soundboard. Now we're going to get into the writing to the soundboard. So we scroll down a little bit more, and here is what it takes to mute the group. So I define a new message, an OSC message, I set the address, which is the IP address of the soundboard, in the port. And the message I'm going to send is OSCADR, which is /group, whatever the first one was, /group /mix/on. And I'm going to send it false, which mutes the group. Because if it's not on, then it's muted. And what the I is you can have multiple values in the OSC message. So this says I have one value I'm sending, and it's an integer. So I'm sending an integer of false. If I had other values of strings and longs and stuff like that, I could put that in here. It'd be I, S for string, and so on, and a comma, and in each value at the end here. And then I send a message to the soundboard right here. And that's it. That mutes that group. Now, here's the unmute group. And you know what I could do to make this much simpler is I could just do mute group and either true or false as an input instead of using two functions. In fact, that's probably what I'll do in the long term to clean it up. Because all I got to do is change this true or false value. If I would pass in true or false, then I would be able to take this variable right from here and use one function, and it'll work just fine. Actually, so I think I am going to do that. Come think of it. And then I do something with mute channel, except this is OSC address 2, which is /CHN/09/mix/on. Again, integer, false. And then here is unmute. So that's all it takes to do the muting of the channel. And then we come down here, and this is a startup cycle, and you'll see I'm just going through a loop with the LEDs. And you can see I had the print line in here at one point for some kind of debugging. I don't remember what it was. Not being used anymore. But anyways, the reason I use the array is I can just use this next pin, and that's how I can go through the entire array that way. Real easily without having to define each individual button. And right here, exactly the same way, I can turn them all off by looping through all 6 of them that are in that array and setting them high, or turning them all on by setting them all low. So that is it for that. So 174 lines, and I have a functioning mute thing. It's not quite where I want it to be. And actually, I can probably do less than that if I clean up my functions a little bit and get rid of the duplicates. Make it a little cleaner. All right, that is it for this week's Let's Make It. It turned out to be a little longer than what I thought it was going to be. I thought it was going to go by quickly because it was only talking about one particular subject. I do want to remind you that we are here every Monday night. We'd love to have you in the chat room. I'm actually been a little bit lax on the chat room tonight. Sorry about that for people that are sitting in there. Let me make sure I have no things to answer. Doesn't appear to be. So anyways, come every Monday night, 9 p.m. and come in and chat with us. And we're talking about I have this working for some other shows already, the ability to dial into a number and chat with us. So maybe we can do that as well at some point if people are interested in doing that kind of thing. And we also, with that, we also have a Skype call in. So if you're out of the country and you don't want to call into a number in the United States, you can call into the Skype ID as well. That's all set up and ready and working. Kind of like what Bob does with video, but we only use audio on the Skype call-in. A couple other things. If you are not subscribed to us, go do that. iTunes. And if you do subscribe to us through like iTunes or Dogcatcher or any of those, they all have a rating system. And it helps us tremendously if you go out there and give us a rating. And it just helps us get found because there's so many podcasts out there that people need to look to try to find the people through the noise. And the way iTunes works is the higher the rating, the easier you are found through all the noise. So we'd love to have you go out there and give us a good rating for that. I also want to mention with Christmas time coming up, we are an Amazon affiliate now. So if you are going to buy things from Amazon, go to tech-n.tv, click on the Amazon link and add it to your favorites. And every time you want to buy something from Amazon, buy it through our link. It just gives us like 2 or 3% of your sale. It doesn't cost you anything. It just money comes to us instead of all going to Amazon, and it helps us buy the things. Like I just had to buy 5 new Arduinos and 5 Ethernet shields because I was running out of the things that are sitting around here to play with without taking all things apart. So it helps us fund those kind of things if you buy things through Amazon. And I definitely would appreciate if you would do that. It's definitely helpful to us. All right. I think that's it for this week. we'll see you all next week, and maybe Bob will be back by then. I don't know. Just hoping he's doing well. So we'll see you all next week on Let's Make It.